if you wanted to compress the sun a lot, by the way, that's actually worked like gravitational potential energy that would be changing, or that's the energy of it. And the energy to compress it is not for free. It's not like you go to the shop and you ask for a sun compression for free. It takes work, and this work, which is equal to energy, would be equivalent to the total radiant energy from the sun over the course of it could have kept us warm for 3 billion more years if it didn't get compressed. Now let's see what this compression story is about as told by Lawrence Krauss. But as I was mentioning earlier about the fate of stars, really the fate of stars is compressed objects, because once the star stops starring, once the star stops doing nuclear power, there is just nothing that can fight against its own gravitation, and it generally will fall and compress. Some of the mass will go everywhere else, like will just go out into outer space, into the interstellar medium. That's how, by the way, we have gas clouds just floating around sometimes, is because it comes off of stars. Like in the course of the star's explosion, in the course of its supernova, sometimes a star will do a big shedding of its outer masses into the outer space, just into the interstellar medium. That's actually how we have a bunch of gas in interstellar medium. Even we come from such a gas cloud or a nebula. Okay, so when a metal-rich star dies and ejects its outer volumes into the interstellar medium, if the star was very metal rich, then the gas going out will be metal rich. We are pretty metal rich. We even have gold on Earth, right? Gold is a very heavy element, aurum, on the periodic table. You can somebody look up what is the atomic number of gold. So that means we come from a pretty metal rich gas nebula that condensated to make the sun and the planets. And so we didn't just come from any old nebula that didn't do much, or came from a star that didn't do much. We came from some star that died that did a lot, and the stars before then, that star did a lot, and then they died, and then they shed their outer layers into the interstellar medium, and then years passed, and then that gas cloud coming from such a star's death condensated, cooled down enough to make the sun and the planets, and that's how we're here. So we come from such stars dying for us, okay, if you will. So 79, okay, very good. So I guess that means that gold has 79 protons in its nucleus. So gold has, wow. So imagine the universe got started with just hydrogen and helium. This has 1 proton and 2 protons in the nucleus. So from 1 or 2 protons, making gold, which has 79 protons, you're telling me, is a lot of work, right? Taking all those lighter elements like hydrogen, 1 proton, helium, 2 protons, lithium, 3 protons, beryllium, 4 protons, boron, 5 protons, right? Going from that to 79 protons in the, am I saying this word right? Protons, right? Sometimes I get the particles mixed up in my brain, especially when I'm speaking. Protons, neutrons, yes, that's in the nucleus. So going from something like lighter elements like hydrogen, helium to something like gold is a lot of nuclear power that happened. It's a lot of nuclear fusion that happens over and over and over in the course of stars' life cycles to then give us something like gold. And then that star died, and then it ejected its material into space, and then that material went and formed a gas cloud, and then that became a nebula, and then that cooled down to making something like our sun and us. And that's how we have gold. See gold right here. I mean, this is probably just gold plated, but that's how we have gold in our jewelry and everything. Don't take it for granted. Do not take it for granted. Gold and silver and uranium, I mean, they made atomic bombs out of that, right? So uranium is what, 92, even heavier element. So don't take these elements for granted. Stars have lived and died for them. Lived and died. Heavier elements come from stars, period. Stars have lived and died for these elements. That's how we have these elements now, okay? So anyways, at this density, the atoms in the sun